things we're going to do is we're just going to jump right in with an example because I think that would be the best way. And so if I gave you the following problem. Oops. If I gave you the following problem. The limit as x approaches 3 of x squared minus x minus 6.
Is this 1, 4?
Still 1, 3. Okay? If I gave you that problem, what would you do?
Put 3 in for the x's.
Put the 3 in for the x's, which is what we learned Friday. And so really I end up getting 3 squared minus 3 minus 6 all over 3 minus 3. What does that come out to be? 0 over 0. Now this is not an undefined problem, okay? And this is why. And that's because it is 0 over 0. Whenever you get something like this, this is what is known as the indeterminate form. And so what that tells you, if you think of that word indeterminate, that means cannot be determined. So as it is written, we can't determine that. So we've got to somehow figure out a way to alter this problem or somehow manipulate it so that I don't get 0 over 0. And the biggest problem is this x minus 3. So I need to think back to algebra, and if I look at x squared minus x minus 6, what do you notice about that? What do we call this whole term right here?
It's one of those things.
Quadratic. Okay, it's a quadratic, and so as a quadratic we can factor, complete the square, graph, all those things. We can, and this one actually is nice because it can factor. So I'm looking for 2 factors of 6 that differ by 1. What are those 2 factors of 6 that differ by 1? 2 and 3. So if you remember, I start by putting an x first, and then I put a 2 and a 3. And you just said negative 3, positive 2, right? So that's how x squared minus x minus 6 factors. And my denominator is now x minus 3. So what do you notice in looking at that? Your x minus 3's cancel. Oh. So really now I have the limit as x approaches 3 of x plus 2. So then now what you need to do is go ahead and plug your 3 in now. And if I plug my 3 in now, I get 3 plus 2, which is 5. You didn't flip everything around. That is the indeterminate form, and that means as it is written, you cannot determine the limit. And so what you need to do is somehow manipulate it so that you can. Yeah. Okay, so you might have to factor, and that's okay. Right? Sometimes those things happen. So let's go ahead and look at another one. Okay? The limit as x approaches 0 okay, of, let's just go, x squared plus x over x.
0. Indeterminate.
Now, when you plug in 0, you end up getting 0 over 0, which is bad. Okay, can't have that. So that means you obviously have to somehow try and manipulate this around a little bit. And what can you do? What'd you say? Somebody said something back there.
Change 0 to 1.
No, I can't change 0 to 1. What? Factor. Factor the top. What can you factor the top and get?
X outside of x plus x.
X plus what? 1. So then now what ends up happening? Your x's cancel, so that leaves you with the limit as x approaches 0 of x plus 1. And so your answer then is just 1, because if you plug 0 in here, you end up getting 1. Okay? Let's look at another one. The limit as x approaches 0 again. Okay, this is probably one I would get down if I were you. But then again, it's your own life. Yes, the minus 1 is outside the square root, correct. What happens when you plug in 0? You get 0 over 0 again. So obviously we have to manipulate this. We can't factor it as such. Okay? And so what this is called the rationalization technique, or the rationalizing technique. And what you've got to do is you've got to deal with that square root. And so what we're going to do is we're going to multiply both the top and the bottom by the conjugate of the numerator. So the conjugate of the numerator in this case will be root x plus 1 plus 1. And you're going to multiply both the top and the bottom by that. Okay? So you're going to multiply both the top and the bottom by that. Now one of the nice things, if you heard what I called that, I called that a conjugate. One of the nice things about conjugates is that you only need to multiply the first terms and the last terms because the middle terms drop out. So all I'm going to do is multiply this times this. And when I multiply a square root times a square root, what happens to the square roots? They're gone. So that really leaves me with x plus 1. Okay, now I'm going to multiply the negative 1 times the positive 1, in which case I get negative 1. Now in that denominator, I want you to not multiply it out. I want you to leave it as x times the quantity x plus 1 plus 1. Do not distribute the x. Okay, don't do it. It's going to cause you problems. So then I've got the limit as x approaches 0. Okay, what am I left with in the numerator? X, because your 1's drop off, right? So then the denominator, I'm just going to leave that as x. Once again, leave that outside the parentheses. Do not distribute. Because now, what do you notice happens? Yeah, they cancel. So it leaves me as the limit, as x approaches 0, of 1 over square root of x plus 1 plus 1. So now what do you need to do? Plug in 0. Okay, so if I plug in 0 here, I end up getting 1 over, what's the square root? 1 over 2, right. There you go. And that is your limit. Okay, but that's called the rationalizing technique. So whenever you get a square root, you need to multiply by the conjugate of the numerator. Okay, any questions on that?
Is that going to be the hardest ones?
Hmm?
Is that going to be the hardest ones?
Yeah, pretty much. Okay, 2 limits I want you to get down. These are special trig limits that we got to cover, and then that'll be it for today. Okay, the first one is that the limit as x approaches 0 of sine x over x, that equals 1. Sorry about that line. Okay, that's your first limit. And that the limit as x approaches 0 of 1 minus cosine x divided by x, that's going to equal 0. Now why they've defined these is because if you plug in 0 as it is, what ends up happening is you get the indeterminate form 0 over 0. And so they've already predefined these, because how do you simplify sine x over x? You can't. You can't just cancel out the x's. Same thing with cosine x over x. You can't simplify that. So those you need to remember. Yes. Okay. Okay. So with that in mind, what I had you go through what numbers on Friday? Was it 40? Through 40, right? You have page 68, I believe. So on page 68, this is what I need you to add to section 1.3. Okay. I need you to go ahead and do 49 through 56. Actually, I take that back.
I can't use pen.
Well, then you shouldn't use pen. 49 through 54. And then I want you to do 57 and 58. And then I want you to do 67 and 68. Okay? So that's what I need you to go ahead and add to your existing assignment. I would expect a quiz probably tomorrow as well.